linear regression. What we are going to learn is simple linear regression, and it is nothing but a machine learning algorithm. Okay, this is what we are going to learn today. So, in terms of interview, this is something is very much, मतलब interviewers को this topic likes the very most. This is very first algorithm that got developed in terms of in terms of machine learning. So people like to talk about this, right? And when we talk about data scientist, this is something हर किसी को पता रहेगा. Every HR, every technical manager will know about this algorithm. So they will definitely ask like 2 to 3 questions. Okay. So 2 to 3 questions will be there for sure. It means what is our duty here? What is our duty here? That we should learn how much, like whatever, like how much, like, there is no limit. You should go like very deep in this particular algorithm. Although you will not implement this algorithm in the industry because this is which are solvable using this simple linear regression machine learning algorithm. Okay, so this is more of like a learning thing that you know, and this will give you the right intro of what machine learning is. And this is very simple also. That's the name, right? Simple machine learning algorithm. Okay, that's the name. So let's quickly dive into it. Before we start, we must know what we are doing. Okay, so आज का goal क्या रहेगा? आज का goal और what we are going to learn in the simple linear regression. Okay, in the linear regression algorithm, what we are going to learn. So very first goal is we should know what we are doing, right? Meaning, uh, what problem we are solving. What problem. Basically, there will be some problem, you will get some data for it, and you will be solving some problem. Okay, using machine learning. That's the we always solve problem. Being a data scientist or anything like when if you are a technical person, you are always solving some problem. So this should be the very first question you should be asking to even your manager also, what problem we are solving. Okay. So now the very first thing we will learn about is what problem we are solving. Second thing that we are going to learn is uh, maybe geometric metric intuition. Okay, and the third thing we are going to do is mathematical intuition. Mathematical intuition. It means we will see first how this linear regression problem is and how we can solve using mathematics. Okay, so there will be some mathematics involved, there will be some calculations involved, there will be some formulas we will learn today, but not necessary that you should remember all the formulas, but you should know the name, you should know what we are actually doing. Okay, so some people will be get scared, okay, what these formulas and all, we haven't signed up for these formulas and everything, so we don't want this machine learning. So don't get scared, this is a simple, very simple algorithm, although, but it will have some calculation, you may have to go through the calculations and formulas and all. Okay, so let's start. Let's dive into it. Yesterday, we learned that is in machine learning, okay, we have supervised, supervised. supervised machine learning, and then the second was unsupervised. Supervised. Okay, there was one supervised, and the second one was unsupervised machine learning algorithm. What had supervised had one more type, that is regression, and it was also having some classification. Right? This is what we have learned yesterday, like motamoti. So we know there are like two types of machine learning algorithm. First is supervised, second is unsupervised, and supervised again have two types. So the very first is regression, second is classification. So out of this regression, we are learning very first type, that is linear regression. And we also saw one thing, regression meaning the dependent variables are what? Continuous. Right? This is what we have learned, right? The dependent variables are continuous variables. What is mean by continuous? Continuous meaning numerical like zero point 0.5, 1, 2, 1200 and so on. Okay, and the classification had some classification problem like true, false, rain, not rain, like this, white, blue, things like it. But in regression, we are finding the dependent variables are zero point 0.5 or 12, 1200, 1500, meaning numbers are there. Okay, numbers are there in the regression. Okay, in regression, we are finding numbers. Okay, we are predicting the numbers or numerical values we are predicting. Continuous variables we are predicting. Let me give you one example. For example, let's say one data set for what data set we can say. Uh, a simple data set can be, mm, mm, mm. okay, let me say like study hours, study hours and marks. Okay, let's say you have this data set, right? So let me just create a data set. And for example, like 2 hours, 2.5 hours, 8 hours, 4 hours, like this data. And let's say marks is like 30 marks, 35 marks, 95 marks, 52 marks. Okay. So these are marks. So meaning for even upcoming exams that will be there on Wednesday for Python, for our class, for you students. So if let's say there is one student who only studies for 2 hours, he may get 30 marks. There is one more student who study for 20 25 2 and 2.5 hours a day, of course, he get 35 marks. And there is one student, very smart student maybe, or hardworking student, I will say, he or she works for 8 hours or study for 8 hours, and he or she may get 95 marks. So this is what the data set is. Okay. Now on this data set, what happens is we train we train we train our machine learning algorithm or machine learning model. Okay, I will say machine learning model, right? We train our machine learning model. So now, when we train our machine learning model, it forms some hypothesis. Hypothesis. Hypothesis meaning this is nothing but a learning of a model. Okay, that model has learned something from your data. So this particular data, uh, this particular data we fed into our machine learning model. It has learned something from this model, and this is the learning stored inside the hypothesis. Okay, understand all these words. Try to understand all these words. So now, what happened is whenever you insert some new data, Okay, new data. Seeing, let's say there is an input of some random number like maybe 6 hours. So it should, by this learning, it should predict some value here. Okay, so it should predict like 70 marks, something related. So that will be the output, or it will give you some marks like 70 marks and so. Okay, so this is how the whole entire training and training the machine learning model and injecting or querying with the new input data happens in the machine learning. So now where this uh, where this linear regression comes in the picture. Okay, let's understand. For example, you have okay, etc. Let's say you have this y column and x column. X not really columns, but x row. Okay, here let me see क्या था यहाँ पर. Let's say इसको मैं x बोलता हूँ, इसको मैं y बोलता हूँ. ठीक है? This is my x column, this is my y column. Now, if I say this is x, meaning this is study hours, right? यहाँ पर लिख देता हूँ मैं study hours. Okay, and this is my y. This can be my marks. Okay, marks. So, for example, there are some students like ये 1 हो गया, 2 हो गया, 3 हो गया, 4 हो गया, 5 हो गया, जो भी है. This is also 1, 2, 3, 4, 5. Based on these points, let's say 2 hours, there was some marks got. So these hours got some marks. ऐसे करके मैंने ये सब ऐसे प्लॉट कर दिया. Meaning, for example, 2 hours के लिए ये हो गया 1, 2, 3, 4 ऐसे कुछ. 2 hours for 2 hours. How many marks how many marks a particular student got? For 4 hours, how many marks a particular student got? Okay, like this, we plotted some points on the graph using the data points. Okay, ये इसको पकड़ के we got this data, particular this data, and we injected those points on a graph. Okay, now like this, considering there are like a lot of points are there. Now what happens is you draw a very close line from the all those points. You try to draw a very close line from this point, and you call that line a best fit line. Okay, remember these names. You called that line a best fit line, right? So now what happened is these are your actual points. These are your actual points. Okay, these are your actual points. This is your best fit line. So here, here we call, like, using linear regression. What we do is actually what we do is we draw this line. जो हमने ये line draw करी है ना, using linear regression algorithm, we try to draw this line basically. Okay, so how we draw that line, I will explain you later. Okay, but now consider we draw this line, and whenever we draw this line, whatever the points you are seeing on this line are called as predicted point. Predicted points. Now I got three concepts. Okay, the very first concept is this line is called as best fit line. These points are my actual points, and the points which are on my line is called as my predicted point. Okay, these all three concepts I got to know. Okay, first, once again, the line which we have drawn using machine learning is called as best fit line. The points which are there which draw using this data set are called as actual point, and the points which are there on the line is called as predicted points. Okay, now I will explain how these points are considered predicted points. So since we have drawn this best fit line, whenever you give the new data, right? We talked here about new data here, right? New data. So let's say you gave this 6 year. Okay. Now you ask for 6 hours of study, how much marks a student will get. So what our model do? Our model will check on this predicted line. Our model will check on this best fit line, and it will cross check the point which is here. And for example, here 97 marks are. And then it will give you the output as 97 marks. This is what happens in the linear regression. Okay, this is what happens. That whenever you give new data, it will plot that point on the best fit line, and then it will cross check what the value is associated with that particular point on the y-axis, on this particular axis, and that will be your answer to your machine learning model. Now, point here is we discussed everything. Okay, we discussed there are some predicted points, actual points, and like all the points which are on this line are predicted points, and that's why we are testing. But what this line, how this line is calculated, how this line is drawn, and I have said to draw this line we use linear regression. Linear regression. Okay, to draw this line we use linear regression. So we see one thing. Okay, whatever points here we have in the line, whatever points here we have in the line are predicted points, and whatever points are here are actual points. So you can see there is some distance between actual, you can see here there is some distance between actual points. This is actual point, this is predicted points. Okay, so if your actual point is almost predicted points, it means your machine learning algorithm is working well. How? Because if your data is that good, if your data is that good, that whatever points or whatever data you have, it has that those patterns that, like, for example, here we can say if the study hours increases, mark increases. Okay, we can say x is linearly proportionate to y, meaning whenever x increases, y increases, right? So whenever x increases, y increases. This is what I'm saying. Whenever x increases, y increases. So if these points are if the actual points are almost predicted points, it means your machine learning model is working very really well. It means you have drawn this line in a very right way. If this distance is very less, if this distance is very less, the points between actual point and predicted point, if the distance between actual points and the predicted point is very less, then the line is called as best fit line. Okay, let me write this. If if the distance distance between actual points and predicted points are very less, then it's a best fit. Okay, now here we get some aim. क्या aim मिलता है? What aim we get? we get to find the best fit line. To find the best fit line. Okay. If the line, like what is the definition of best fit line? The distance between actual points and predicted point is less. Okay. This distance is called as residual error. Residual error. Okay. The distance, okay, यहाँ पर let's write a definition. Residual error. Distance between actual point and predicted point. Okay, the distance between actual point and predicted point is called as a residual error. It means if the residual error is less, if the residual error is less, it means the quality of prediction, I would say prediction must be high, right? Agar error, if this error is very less, if the calculation like summation of this, summation of this, summation of this, like all the distance from the actual point and predicted point, actual point and predicted point, actual point and predicted point is very much less. If it is less, it means the all the points are already almost on the on the best fit line. It means all the actual points are actually predicted points. Okay? So if the residual error is less, meaning the distance between actual points and residual point, actual points and predicted points are less, it means the prediction or the quality of a prediction is high. Okay, try to understand this. This may you may find this somewhat very unusual, very new, but try to understand. If you don't understand, doesn't matter. But stay with me till the end. It will make sense. Okay, let's look at all these things like a story. Okay, so there is some points, data points we plotted on a XYZ chart. Then we draw a very best fit line going through all the points. And now we are calculating the distance between those points and the points on the line. And whatever points there on the line, those points are called as predicted points. So basically, we want such a line which passes through all the points, or we want such a line which has a very less residual error. Okay, which has very less residual error. Meaning, let me just draw one more line. Alright. Okay, here, 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 here. So this distance, this distance, this distance, this distance, this distance. If you add this distance, 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 if adding all this distance is residual error equals to, for example, 50. Okay, so let's say this is 10, this is 10, this is 10, this is 10, this is 10. The new residual error is 50. Okay, now for example, I have drawn one more line. Okay, and now distance between this, 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 and this new residual error is, for example, new residual error is 1 second. New residual error is 40. Okay, so we will call this line as best fit line, not the this one. Okay, so you must be must have got the point now. So logically, we will be drawing thousands of lines like this, thousands of lines. Okay, the machine learning model will draw thousands of lines and try to find the residual error almost zero. Okay, almost zero. So it will not be zero. If it is zero, then the condition is called as overfit. So that we will learn later. Okay, so it will try to find a line which has a residual error almost zero, which has a residual error almost zero. Okay, it will not be zero soon. Like you have to like draw very different lines and all. So how do we calculate this residual error? First of all, okay. So if the error is less, it means the line is best fit line. Okay. Our first question was here. The aim was how to find the best fit line. Okay, that was our aim. Now the aim has been shifted. How to find this residual error is less. Okay. So let's come to the some calculation parts. Okay, try to understand some formulas and all. So now this will require some mathematical knowledge, some basic math we should know. Some basic math includes what is the equation of line, what is slope and all. But if you don't know, you will get to know. Okay. So in maths, for example, if we start maths now, okay, to calculate to draw a line, let's say, okay. So if I even draw a line like this, okay, it has some starting point, right? It means we need a starting point. Okay, we need some starting point. And from a starting point, I can draw here also, I can draw here also, I can draw here also, right? So to know where the line is going, you should know the slope. And what is how the slope is calculated? Slope is calculated this angle. This is slope. This is slope. This is slope. Similarly, this is called as slope. So here we call this theta. Okay, where we call this theta. So we got to know to draw a line. Okay, to draw a line, draw a line. We need first starting point and we need a slope. Okay, we need starting point and we need a slope. Here also, here also, we need a starting point. You can say this is starting point or this is starting point or this is starting point, and we need some slope. Okay, here if you try to see. And if we know these two things, we know what type of line we are drawing, where the line is going. Okay. So the line equation is line equation. So the line equation is y equals to mx plus c. So this is the equation of line. So y is basically I will say slope, m is slope, c is interception, interception. Okay, this c is interception, m is slope, and x and y are our x-axis, y-axis. Okay, meaning if we come here and if we talk about this chart, so this is my x already, we already know. This is my y. Okay, this is my c. C meaning interception at x or y axis. Basically interception at y axis only. Okay, where my line is intercepting on my y axis, and this is my slope. Here you can see this is my slope. So this will be my m. This will be my m. Everyone got this formula? Y equals to mx plus c is my final formula which calculates how I can draw the line on x and y axis. So let me just draw a quick diagram. quick diagram for you here also if you if you need this. Okay, let's say this is x, this is x, this is y. All right. Let's say you are drawing a line like this. So this will be your C. Okay, this will be your intersection, and there will be thousands of points, right? Everywhere. So how the slope is calculated for some, let's say here, this is one, this is two, this is three, this is four, and this is also like one, two, three, four. Okay, so the slope will be calculated in such a way that for, let's say, 1 unit of x movement, okay, listen carefully. For 1 unit of x movement, okay, from on x line, we are traveling from 1 to 2, meaning from one movement on x to y, how much we are moving on y. Okay, how much we are moving on y axis. And when you want to find that, you calculate this this theta, and this is called as your m. Okay, m is also called as I think coefficient, coefficient, coefficient. Okay, so how much displacement is there when we move on x-axis for a 1 unit? How much distance or a displacement happens on the y-axis? Yeah, tan theta maybe. Maybe I am not sure. Yeah, tan theta maybe. Tan theta. Let me. Okay, let's not go there. We can say tan theta formula. Tan theta will be adjacent side one opposite upon adjacent is tan theta. Maybe the opposite upon adjacent, probably Chirag maybe. But as of now, let's understand. We don't really want to go there. We will assume this. We always assume this m value. So I will explain you this really quick. So as of now, I got to know this is my line equation y equals to mx plus c. I got to know what is m. I got to know what is c. C is my interception on y-axis. I got to know my y is always my predicted value. So this is gonna be y hat. Okay, y is my predicted value, and x are the points in the data set, like these x1, 2, 3, 4. Okay, these are my x points. Right. So this is how my entire equation says. Now, this is a somewhat old, old, what I would say, equation. This is not the very latest equation. Okay, my charging is a little less. Anytime the laptop can go die. Anytime laptop can die. So we may have. Okay, I will just take 5 to 10 minutes more. All right. So in data science, they have a very similar formula. Okay, they have almost similar formula. So what we have written is y equals to mx plus c. So in this data scientist, or there are some scientists, they have developed a similar formula that is called as h theta of m, or not m actually, h theta of x. H theta of x. So they are saying for this c, or like mx they refer theta x, theta 1 x1 plus theta 0. Okay, so this theta 0 is my interception. Theta 0, here let me just write, theta 0 is my interception. Theta 1 is my slope. Okay, and here I will say h theta of x is my y, right? It is exactly the same. But now when you see x has multiple values, x has multiple values, 1, 2, 3, 4, 5, 6, 7,000, 2,000, right? So it means I will be writing like h, it means I will write h theta of x equals to theta 1 x1 for this 1, theta 2 x2 for this 2, theta 3 plus x, sorry, theta 3 into x3 plus and so on till theta n. I will let me write here theta n xn plus theta 0. That is this interception. Okay, so this is how the line or calculation happens on this particular formula. Okay, so if you have like thousands of points, x value can be like thousands of points there. So you can calculate your y ka value. You can calculate your y's value based on this. So here we need some theta x ka value. Okay, some theta meaning this angle, this particular angle, and x ka value, x value, x1, x2, x3, x4, x, and so on, and the interception. So if you know this interception, if you know this x values, you can get this your predicted value. Okay, somehow we are going somewhat near to our problem statement. Okay, so when we will be completing this, you will be like little shocked that okay, how did we got this problem solved? All right, moving little ahead. Okay, moving little ahead. Let's go with some calculation. Let's try and do some calculation. So, mm, so initially, what we do is, but sir, this angle is 90 every time. Uh, okay, so maybe I may have mistakenly said this angle. Maybe this angle that you are saying tan theta. That can be possible. But in terms of machine learning understanding, we need this line slope. So maybe this one. I need to see. Okay, let me just quickly look at line slope. Line slope formula on x and y axis. Hmm. Okay, you're not looking at my another screen. Yeah, this is the different theta. This is the different theta. Yeah. So we were discussing about we should have been discussing about this theta, this angle. So you were actually right. This was tan theta. Okay. So opposite side upon adjacent side. Opposite side upon adjacent side. So we were discussing about this theta, not this theta. Okay, not this theta. Coming back, coming back. All right. Now, now in machine learning, coming back in a machine learning, let's say, let's say we have some hypothesis. First hypothesis is considering. mm, let's write our equation. Maybe we can do this and close the lecture. I have only 6% of charging. Okay, so let's say we have this hypothesis. Alright, that was a good catch. Chirag, that was a good catch. Okay, so we have this sum hypothesis. The hypothesis is h theta of x theta 0 plus theta 1 x1. Okay, so this is nothing but our slope, right? And this is nothing but our interception. Okay, I'm repeating these things so many times so that you understand. Okay, so that you understand. So now for example, यहाँ पर ले लेता हूँ कि x y axis, x axis. Okay, this is x, this is y. Now for example, if I considered theta 0 is for example 0. Okay, theta 0 is 0 and theta 1 is zero point 0.5. Okay, so initially what happens, we go with a random value. Okay, we go with a, so theta 0 is my interception. Okay, theta 0 is my interception, which is a 0. And now theta 1, which is my slope, is considered as zero point 0 at the moment. I have just assumed this. Okay, I have just assumed. So my formula was this: theta 0, theta of x, h theta of x. Now, फिर से लिख देता हूँ, let me theta 0 plus theta 1 x1. Okay, and I have some values on x, 1, 2, 3. Okay, 1, 2, 3. There are some values, and there are some values on here also, 1, 2, 3. Now, we said theta 0 is 0, theta 0 is 0, theta 1 is zero point 0.5 into x, x1 is what? 1. x1 is 1, right? X1 is 1 plus zero point 0.5 into 2 plus zero point 0.5 into 3. So this is my theta 2, theta 3, theta 1, x1, y1, x1, x2, x3, x1, x2, x3. All right, x1, x2, x3. So this will be like, yeah, this will be zero point 0.5, 1 plus 3 somewhere around. The output will be, कितना आएगा? Uh, yeah, this will be, yeah, total there will be 3, but pointing the points, for pointing the points, so this will be zero point 0.5. Zero point 0.5 into 1 is zero point 0.5. So we will plot point here, zero point 0.5. Then इसका calculation आएगा 1. So we will plot somewhere here maybe. And this will have 1.5. So somewhere here. Okay. This is somehow we calculate. And later we will be passing the lines or drawing the line. So this is how the line comes out. Okay, this is how some interception point